Hi, everyone. Welcome to September's Meanwell Tech Spark. I'm your host today, David, and we are joined with our technical service manager, Brian. Thank you for your help. Today, we'll cover Meanwell's large range of battery chargers and we'll show some application examples. Brian, can you get us started on how we think about chargers and divide them up?
So let me share this, hit up the screen here real quick. 1 second. Okay, so as you know, Meanwell battery charger category is very wide. So I broke them down to like 3 main different kinds, so you guys can easy to remember them. So the first one is what I call it external and built-in tap. Okay, they're like customer can use them externally or built into a system. So externally, for example, you to charge electric scooter, okay, or internal for a UPS application. So within this external and built-in tap charger, we have 30 watt up to 1700 watt, okay. And so we have the GC and the MPB series are the two external tap that range from 30 watt all the way up to 360 watt. So you see the photo is it has the DC output cable where customer usually plug it into the battery or the scooter to charge the battery. And those also come with like 2-stage or 3-stage. And the second one is the built-in tap. Okay, built-in tap, you can see it like it's a terminal. Okay, it's a terminal output that a battery is connected directly to the charger. Okay.
And interesting that I see here is that the NPB series, Brian, has that cable and terminal output style. So that's interesting to see. Given that they also have the 2 and 3-stage charging, can you tell us a bit about the differences between the GC and the NPB and the NPB versus the NPP series? How are those different?
Yeah, so sure. The GC is what we call first generation external charger. So it's fixed the voltage and charging current. Okay, but the second generation, this is the NPB external. If we make it more flexible for customer, okay, it had a step switch to switch the charger between 2-stage or 3-stage for different type of battery, or whether the customer need to condition the battery. And also is able to set the output voltage and current, the charging current for different type of battery. So in short, the NPB charger is the second generation will make it very like flexible for customer to choose for different type of battery use. And for the MPP, Peter, and the MPB, the main difference is that the MPB is a charger only, but the MPP can be used as a power supply or a charger. Okay, we have a lot of enclosed type power supply, RSP320, RSP500, those ACR terminal block. Okay, but we have sometimes customer ask us to do an IEC inlet, okay, power supply. So that's why we have the MPP. So MPP can be used as a power supply as well, and it also comes with an IEC inlet. So that's going to fulfill the some demand that need a power supply as a IEC inlet.
Got it. So in summary, regarding the external chargers, the NPB is the newer generation that has that flexibility to use 2-stage and 3-stage charging, as well as adjusting the charging curve for it. And regarding the built-in chargers, I see that the NPP and NPB are similar in name. Can you tell us a bit about why we have P and B? What do those stand for?
Yeah, I just mentioned is it's just the MPP is a power supply and a charger.
Oh,
You can configure them. Okay. So the next part of charger category is harsh environment.
Yes.
Okay, we have a charger that the harsh environment we have is from 600 watt up to 2300 watt. Those are fully encapsulated. Okay, suitable for use for charger that for you outdoor use, for high moisture and high vibration. So application, for example, if customer want to charge a golf cart, okay, a golf cart with built-in charger, you want to suggest the customer use the HEP inside the golf cart because the golf cart, if you go every get pumped every day, you want to use a power supply with potting. Okay, and other application like a drone charger. Okay, drone charger customer also use this HEP series because those chargers usually being used outdoor. Okay.
Got it. And then in terms of the details on the durability in water and dust, these units are IP rated 65. Brian, I also see these HEPs as regular power supplies. Is that right?
Yeah, I mean, we ship them out as a power supply, but the customer can use a CAN or PM bus or the programmer to set it to a charger. Okay,
Oh,
it's
wow.
like a dual function. It's similar to the MPP. Okay, but we set them as a power supply, and it's capable to be used as a charger with a three-stage charging curve and programmable as well.
Got it. And then I'm excited to see the last category, the intelligent chargers.
Yeah, intelligent. We call them intelligent. For the intelligent, we have very high power range, including rack version. Okay, we have the 1600 watt up to, 450 watt all the way up to 320 watt. And the 320 watt, the rack power also can be in parallel up to 12K, okay, 12 kilowatt to charge the battery. And so we call them intelligent because this category can be programmed. Okay, the charging curve can be programmed to charge different type of battery that we offer. Like we have the programmer, the SPP001. Customer can connect it to the power supply, the charger, program the charging current, program the charging voltage for different type of battery bank.
Got it. Okay. So given that these have the PM bus and CAN bus protocol capabilities, they are intelligent enough to communicate, as well as, the ECN, has the option to use this programmer for.
Yeah, so speaking of PM bus and CAN bus, it's become important for some applications such as like a robotic charger.
Yes.
They want to help the customer want to have a display showing what is the remaining time to charge the battery. Those information need to communicate to the CAN bus. So that's why we have a new generation charger all come with CAN or PM bus for customer to adapt.
Got
Okay.
it. Thank you for the summary on all these series. And then kind of stepping back to the left, I see that they have a commonality in terms of this charging stages, right? 2 or 3. Can you tell us first about charging stage 3?
Yeah, I will, I would do it simple. 3 stage, so it's by its name is, it's the charger battery in 3 different stage. And so I'm showing the drawing here. In stage 1 is the constant current, okay, where the charger is outputting a constant current to charge the battery. So let's say if the battery is 12-volt battery, when it totally discharged, it's like 9.5. And then when you turn on the charger going to output like, if it's a 10 amp charger, it's going to output 10 amp charging current to charge the battery, and then you will see the charge voltage slowly ramp up. Okay, when it ramp all the way up to the set V boost, okay, the charger will enter the second stage. Okay, at this step, for the second stage, we call it constant voltage, meaning it's going to output like a 14.5 volt to a battery bank, and then the output current slowly ramp down. Okay, you see it's the curve slowly went down, and then when it went down to like 10% of the 10 amp or 1 amp, then the output voltage automatic flow down to 13.5. So that's what we call is a flow stage, okay, to maintain the battery.
Okay, and I see that we have, a variety of batteries to use in our applications. For 3-stage charging, what battery is best suited?
So it's a good question. There are no really specific which power battery type suitable for which stage. Lead acid battery usually being used for usually use a 3-stage charger, mainly because lead acid battery its cell discharge rate is high. Meaning that if you full charge the lead acid battery, you leave it on the shelf after like a week, you may see it drop down to like maybe 85%. Okay, and that's why if you want to keep the battery flow charged, okay, you want to keep it fresh all the time, full charge all the time, you want to flow charge them. That's why 3-stage coming in to flow charge and maintain the battery energy.
Got it. And I think my understanding of 3-stage overall is, when the battery is not at full capacity, it can maintain that constant current, ramp up the voltage to the voltage of the battery, and then it will maintain that voltage and reduce the current in the second stage. And when the battery reaches around 95% full, then it will drop down into the third stage of the V float and the current float as well. Is that right?
Yeah, that's correct. Yeah, that's how three-stage charger work.
Excellent. Can we see an application?
Yeah, sure. So I want to share, we work, some of the application is popular one is the wheelchair scooter. Okay, so this application, the a customer use a 75 mAh Shield AGM battery. Okay, because it's lower cost as compared to lithium-ion battery, and they chose the 360-watt AM charger. Okay, AM charger, and there's a criteria when you select a charger versus a battery. Okay, so in this case, it's a lead acid battery, and you usually suggest to use 0.1 C to 0.3 C to charge the battery. It cannot be charged that high current. It's not good. The lead acid battery cannot handle it. So that's why the customer chose AM. Okay, they use 0.1 C to charge the battery because this application basically used in when at the grocery store like from 8 to 9 p.m. After the store closed, they will charge overnight. Okay, so they have more time to charge the battery overnight. Okay, and once it's full charge, it can use the whole day. Okay, so that's why the customer is go with a little bit high mAh on that acid battery and use this external charger. I mean, they use like, they plug in a wall and then plug the charger in and then leave it overnight. They don't want to have it built in. Yeah.
Got it. So it sounds like, lead acid batteries typically encourage slower charge times in applications where they can afford that, like this one where, when the grocery store is closed, they can charge it overnight. Using something like the NPV that has that three-stage capability is a perfect fit. That's good to hear.
Yeah, I mean, in this case, the charger also able to adjust the current as well and the voltage.
That's right.
For different AGM battery or different charging current, they want to slow down the charger, they can do that as well.
Excellent. And let's see another example.
Okay. The next one is a UPS. So we have like a customer use an inverter. They help they're building a UPS system for PoE. Okay, loading about 500 watts. So they were doing like they purchased the RPP 1600 48 charger and then use to power the inverter and also use to charge their battery bank. So when their power outage, okay, the battery would power up the inverter and continue powering the load. Okay, so that is the UPS application. And for this case, it's special because the RPP 1600 itself, it's a charger, but it can also be programmed. It's intelligent. It can also be programmed to become a power supply. Okay, the customer program it to become a power supply and lower the charging voltage, because this application, the load is always there. Okay, if you use a three-stage charger and there's a load on the charger all the time, okay, it will never enter the third stage. It always stay at second stage, and for prolonged time, it's not good for lead acid battery. It may boil it. So the customer was able to use the programmer to program the RPP 1600, lower the voltage. Okay, so that it does not boil the battery.
Got it. And then I see this setup, looks very space consuming and complicated with all the connections. And I believe recently Meanwell released the NTN 5K that has the whole package together of an inverter and a charger. So, for the NTN, you can have it connected to the AC grid and a charger, and in that mode, charging the battery. And then when the AC grid loses power, it can switch automatically into the inverter battery mode and using the battery for the AC output.
Yeah, I mean, NTN is the only one. So, if we have the NTN at that time, the customer would purchase the NTN. They don't have to, do two and then do all the wiring. I mean, it's able to charge up to like 5K and then also programmable as well. And then it's scalable. It has parallel function as well. So, but I mean, yeah, NTN is the solution, it's the one two-in-one solution, basically.
Okay, awesome. And then let's talk about that two-stage charging now.
Okay. So for two-stage charging, it's just very similar to the three-stage. Okay, it's go to like constant current and then constant voltage. When the charging current reduced to out to 10%, it automatic go to remain at flow, meaning it's on the voltage doesn't drop down. It's remain like 13.5 if you set it to 13.5, or 14 volt you set it to 14 volt. Okay, so that is a two-stage charging. And for Meanwhile, we have two different kind of two-stage charger. One is we shut down the output when the battery is full, meaning when the charging current is 10% or less, it shut down the power. Okay, the other one does not. Okay, we do this two different kind of charging curve because some lithium-ion battery, the BMS require power to do the cell balancing. Okay, so some BMS that is very expensive and high quality, they are able to do cell balancing without power charger connect to it. So let's say if you full charge the lithium-ion battery, you put it on the side, okay, the BMS itself automatic cell balancing the internal cell. So for example, a 12 volt battery, lithium-ion battery, it has 4 cells in series, right? And each cell is about 3.6, 3.7 volt, and then full charge at 3.8. To balance each cell voltage, the BMS is able to do it when the battery is stand on the cell. Okay, so that case, the customer don't need to use a charger that have output voltage, and some BMS with lower cost, they would require a power supply to flow the voltage so that it take power from the power supply to all the charger to do the cell balancing. And that's for the battery itself, but some application, okay, for example, for robotic application, when the robot is fully charged, when it left the charging dock, customer tend to want the charging dock to turn off.
Yes.
Okay, automatic turn off as well. Of course, they can use RC function to turn off, but they want to turn it off. Okay, so that is another reason why we have some charger that turn off and some charger does not.
That makes sense. And then I heard you mention the lithium-ion battery as a suitable battery for two-stage charging. Is that correct?
Yes, a lot of customers use it for two-stage project, unless you want to use it for UPS application. Then the charger with a full charge would suitable.
Got it. And is it correct for me to say that because the two-stage charging can handle, or the lithium-ion battery can handle a higher charging curve, it can charge faster? Is that right?
Yeah. I mean, the characteristic of lithium-ion battery is that it's be able to do very fast charging, like a 1C, meaning if you have a 100 amp battery, you can use 100 amp to charge it. Okay, and that's why some robotic application, they want to use this two-stage to quickly charge the battery. Charges, I mean, when they go to finish the two-stage and then it go back to work. They don't have to keep it on three-stage.
Got it. Let's take a look at an application using two-stage charging.
Yeah, so one of these application is the electric bike. Okay, so the battery that the customer integrated into the bike is 13 amp hour. Okay, and they chose to use the external charger, the 360 watt 6 amp to charge the battery. So it's able to charge basically full charge the battery in about 2 hours. Okay, 2 hours to full charge the battery. And another reason the customer chose this NPP charger is that they also do the EU market. Okay, in EU, this application or this car is considered home use. Okay, it requires 60335 certification, and the NPP has them all. It has 60335 for EU and also has listing for USU. So customer don't really need to purchase like true charger. For this application. Yeah.
So the reasons why we're selecting the NPB here is because of the lithium-ion battery application. We can switch it into the two-stage mode, as you've seen before with the wheelchair application. You can use the same NPB series, for three-stage charging. So it's very flexible in that. And additionally, there's that bountiful number of certifications, for the US and EU. So That's good to see. Can we
Yeah,
look
let me
at,
go to the, yeah, we have another application. So this is
yes,
the robotic is getting become more popular. So in terms of robotic, there's always a charging dot where the robot go back to the automatic go back to the charging dot to get charged. And depend on the application. Some of them is being indoor, some of them being do outdoor, like for drone charger. And so we have the MPP for be used if it's for indoor use, okay. And then we also have the HEP series for outdoor, okay, for outdoor charger. And for this application, a lithium-ion battery is usually used. Like I mentioned, they wanted application wanted to be a fast charge, okay, charges as fast as possible, and then the robot go back to do to its duties, okay. And main function is the on-off control. Okay, the customer need application need to have the on-off control. So when the robot is fully charged, when it left the charging dot, you're going to want to remove off. Okay, remove off the charger because in case someone touch it or a screw or a nut drop into the terminal, it won't create hazards. And in terms of certification, it's also required to get the required to turn off the charger as well. And also the PM bus and CAN bus.
yes.
Okay, those protocol also important for this application, like because you always want to show how much charging time left, what is the battery health, okay, and what is the state of charge. Okay, so basically those are the mandatory. It has to be done by CAN or PM bus.
Got it. And then in these robotic applications, I think a good takeaway is, when they are charging in an outdoor environment, we want to recommend the HEP. And then for indoor, you can look at something like the NPB. Is that right?
Yes, because the MPB is very cool. Indoor is okay. I mean, we still suggest customer to put like a filter for the enclosure for internal. But for outdoor, the HEP 1000 or the 2300, okay, can be used for outdoors for to do against the moisture or some moisture in the morning. Yeah.
Got it. And I think we have one more application example to look at.
And so this is a last example is inverter and charger combined. Okay, is for mobile workstation. Okay, the battery also a lithium-ion battery because it need to be a fast charge and then so that a worker can use it. And for this case, the battery bank is 500 watt-hour. Okay, and the customer use the MPP 450. Okay, to also 450 watt to charge the battery, meaning that it's be able to charge the battery within fully charge the battery in 1 hour.
That's very fast.
In 1 hour. And also the NTS 1700 was also used to power the all the equipment like printer, laptop when using in inverting mode. Okay, so basically when it need to charge, it go back to the plug into the wall, charge and unplug, and then the inverter would provide power to the monitor and the printer and stuff.
Got it. And I think the last point I see here that we have NFC programmability. I think this is relating to the Meanwell app that we can use to change the current voltage.
Yeah, I mean, the customer want to set up by setting the charging voltage and current by NFC. Okay, make it easy, convenient for them. They just open the box and then without power, they can set the charging voltage and current. Okay, much easier and faster. Because for this type of workstation, mobile workstation, there are many different kinds. Okay, sometimes they have to custom make with a longer operational time, meaning they may have to change a larger battery or lower battery, or change the battery voltage to 36 volt instead of 48 volt. So the NFC make it easy for customer to set the charging current and charging voltage.
Got it. Right. So in this case, if they need to swap out the battery for something else, they can easily adjust the charger to meet the specs of that battery. That's very useful. And then lastly, I'd like to look at how we recommend a charger given a particular application.
Yeah. So usually, we usually have customer or FAE asked about, what do you suggest when customer need the charger? So I list out 4 points. Okay, application. Okay, we want to know what is application, because like I meant, like those application earlier, some would like to have a quick fast charge. Some is UPS, you don't want to boil the battery. Okay, some of them is portable, some of them integrated built-in tap. Okay, so we want to understand, know about application. And the second one is we want to know about the battery tap and its rating. Okay, because lead acid battery, then we need to you don't want to boil it. We want to use like 0.1 to 0.3 C. So we need to suggest a lower current to charge lower current charger to charge the lead acid battery. But if the battery is lithium-ion battery, okay, we can suggest a higher charging current to the customer. And that also related to the charging time, right? We need to understand how fast, what it does, what this application does, how fast you want to charge the battery, and how long you want it to operate, and then come back to charge again. And the last one is communication protocol. So what kind of communication protocol do you need? The customer need to do some display or showing the state of charge of the battery. So those are these 4 are the important information that we need to obtain from the customer to suggest a battery charger.
Got it. And then in cases where the customer, is still selecting a battery, Brian, can you tell us about what we have at Meanwell?
Yeah, so we have we also offer battery now, so it's become like a all-in-one stop. So every time customer purchase or ask about a battery charger, they will need a lithium battery. Okay, so meanwhile now we offer the lead acid battery, the DJM and FT series, that is offered from 38 mAh up to 150 mAh battery. Okay, for customer, convenient to become like a one-stop charging.
Got it. So
Shopping.
in summary, it looks like, we want to first look at the application. Sometimes it's even an outdoor application, right? So you need that durability, like in the HEP series. And then next we want to look at the battery types, either lead acid or lithium ion batteries, to see what kind of charging curve we want to best pair it with. And then in cases where, they're looking for a battery, we have our own batteries to support them. Charging time also, I believe, is a factor that's kind of mixed in with the battery, and the charging stages, if you want to go fast charging, or if they can afford the slower charging overnight. And then lastly, if they need that communication protocol that is, becoming more popular with having more intelligent systems, especially like you mentioned before in those robotic cases where they need to see the charging speed and charging time in real time. Is that right?
Correct. Yeah.
Excellent. Alrighty, and then that is it for our Meanwell Tech Spark regarding chargers. Over here is our kind reminder on our technical team. We have Brian, ourselves here, Kareem, and Harlan. And you can feel free to reach out to them. And then for our next Tech Spark, it'll be introducing the Meanwell New Jersey Service Center with Fred and Jessica. And I was also told that there will be a special surprise in store for them.
Oh, really?
Yeah.
Okay. Cannot wait.
Make sure to mark your calendars.
Okay. Thank you.
Thank you.